your end as well. Oh yeah, that question. I remember that one. 24. We've done that. The loudness one we shouldn't have. Maybe you did it for homework. Or maybe I did it with the next class and you
I know exactly do that.
No, we shouldn't have it. That's a hard one, which we will do. And if I'm not wrong, I think that was in the trial paper this year. Oh, just so you guys know, like even in the extension 2, I'll show you all this in a second. Right? The last question in the extension 2, this whole last question, which is my job, just so you know. That's why you guys are here. But I'm just trying to reaffirm why you're here compared to your teacher or what you're learning from your teacher. And solutions to it. That whole last question, again, that this integration, you can't see around too small. That exact question is just in my notes. So my extension 2 student will look at it going, what? Really? The last question? And perfect. Like you're actually laughing when it happens. And it's happened pretty much every year. So these notes are there for a reason. I've made them a little bit harder for a reason because these are, like this loudness one, it is as hard as it gets. You master it, you won't see it this exam, fair enough. You might see it in your half yearly. You don't see it in your half yearly, fair enough. You'll see it in your trials. You don't see it in your trials, you'll see it in your HSC. It will come up is what I'm trying to say. That's how these booklets are made. But I'll show it to you. The scariest one was, I think, in 2017 or something. I specifically got a ski question. A guy skiing and everything. You can't find that question, except if you're a mathematician like me and you're widely read a lot of different math books. So I chose this particular question. They chose the exact same ski question. Yeah, because like it's identical. You're going to see my guy. You're going to see this question. You're going to be like, weird how identical it was. So this was in this year's. This was in this year's trial HSC for the Catholic paper. So the ones you guys would have sat, this would have been their question. So again, my students would be like, perfect. If you had studied my books, if you hadn't, if you were going through your textbooks and stuff, a whole different story. So nothing fancy about it. It's just a HSC question. I'm not telling you that this was anything. It's just a HSC question, but this is as hard as it gets for max min problem. So have a read first before I get started. Just have a read of it. I'll take my solutions out as well, so we make sure we're following everything right. We'll keep going. As you're reading, if there's any questions you have about it, let me know. Okay, let's get started. We've read it. Confusing, right? A lot of weird words and stuff, but you've got to try to remember, you're in advanced math, eliminate a lot of the crap. Once you know it's part of calculus because of this word, let's say, you know it's a min-max question. Once you know it's that, think of differentiation, blah, blah, blah. All right, here we go. Let's start. All right, let's read. The noise level N at a distance d meters from a single sound source of loudness L is given by this formula. Fair enough. Two sound sources of loudness L1 and L2 are placed n meters apart. Fair enough. That's all you can do, right? If you've never seen it, you just accept it. So fair enough. The point P lies on the line between the sound sources and is x meters from the sound source with loudness L1. So P is x meters away from L1. Not that it's asking, but I'm going to ask it. What would you say this distance? Just so we're all on the same page. M minus x. It doesn't ask it, but my logic says somehow, sometimes you need that, so why not just put it? So it's good to get used to that. Write down a formula for the sum of the noise levels at P in terms of x. Write down a formula for the sum of the noise levels at P in terms of x. Okay, so the noise level I is n. Will we agree with that? N. N equals L on d squared. And what does d stand for? The distance of what? A distance meters from a single sound source. From a single d from, yeah. So look, you know how I just fudged that m take away x? You actually need it. Because you need the distance from P to L2. But like I said, I don't know, over the years, you've done area questions, perimeter questions, whatever. You've done stuff like that. You've got to just do that without it asking you to do it. Before I started, I did that. I'm going to continue. So n equals L, let's call it L1 on what? Squared. What's the distance? X squared. Plus L2 over, I like that, thank you. All squared. M minus X, all squared. Finished, you got one mark. Weird. We've never seen it before. I've never done it before. Whatever else you want to say, I agree with you. But like, come on, it wasn't bad. Now you've got an equation between n and x. Why did I say n and x and not like L and m? What do you know about L and m specifically? Compared to what happens with x. I think the word I'm looking for is either starting with C or V. So L is a C, and M is also a C, starts with a C. X is a V. What's the word I'm looking for? Think of it. C's and V's. Those who do science should know these words. C's and V's. And constants and variable. What is a variable compared to a constant? Yeah, you know it like that, but what does a constant mean then?
Constant.
Constant stays the same. Make it easy for yourself. Constant is fixed. It stays the same. So give me an example of a constant. You would say 2, 3, 8, 10. That's a constant. It doesn't change. What's a variable? You said any letter or anything. It is, but it changes. Because the letter is X, it can be 1, it can be 2, it can be 5, it can be 10. So it's a variable all of a sudden. So when I told you y equals 5x plus 2, hypothetically, 5 and 2 are what? Constants. X is your variable. So when you're differentiating this, what is the derivative of 5x? Well, you only look at the x and that becomes a 5, but what happens to constants? In this case, disappear. And that's how you have to look at this expression when we're going to differentiate it. You got to think about what is a constant, what is a... So, one more time. This would be a variable, variable, variable. The rest are constants, constant, constants. Maybe write it, don't write just C's, you might not know that. Just write constants. Sounds good? Because I know to you guys it just looks like letters. You can't see it like letters. You've got to actually say some things are numbers. L is a number. M is a number. All right. Any questions from here now? Double I. There is a point on the line between the sound sources where the sum of the noise levels is a minimum. Find an expression for x in terms of m, L1 and L2, if P is chosen to be this point. See how fancy it is? A lot of students come to me and say, I don't know how to do double I's, even though they've done I. I'm like, what have I always told you what double I is? What do you think you're going to do in double I? Yep, and what are you specifically going to do with I? Think of this whole topic. Stop looking at it. Say it again. Differentiate. When you differentiate, you're going to make it equal to? Then once you've done that, you have to Fair enough, you can differentiate again, but what's the point of that? What are you trying to do? What are you trying to do? What's that N word? Nature. We're trying to find nature. You can do it with y double dash or y dash table. Done. That is how you do all these questions. So don't read double I. One more time, I'm going to read it. But don't read double I and go, how do I do double I? Don't do that, because once you see the word minimum or maximum, y dash equals 0, find the nature. That's the word. There is a point on the line between the sound sources where the sum of the noise levels is a minimum. Find an expression for x in terms of m, L1, L2 if p is... I don't get it. Don't do that. Right? We're not going to do that. We agree with it? Let's do it. dn on d, what letter? X could give equals 0, stat points. So here we go. dn on dx equals... do you like it written on x squared? No. So we already know we can't write something like this. Let's change this one here to this. L1 x negative 2 plus L2 m take away x to the power of negative 2. I forgot to say, this is your band 6, right? This is not your standard question like stationary points, whatever. Yeah, this is 9900, not just band 6, 9900. Band 6 is 90. This question is 9900. Let's keep going. dn on dx. Okay, here we go. Bring the negative 2 down. L1 x negative 3 minus 2 L2 m take away x negative 3 times the derivative of the inside. So times by negative 1. Now this is where some extension 1 students would have an advantage just because they're comfortable with the algebra. As an advanced student, you've got to start doing a lot more of these, so you can also be comfortable with the algebra. You know what I'm going to do? I'm going to just make it equal to 0 and start solving for x. There's nothing else for me to do. It looks weird, but it's what's required. So here we go. Okay, negative 2L1 on x cubed plus 2L2 on m minus x cubed equals 0. Any questions at this stage? Nope. Next one. I would plus this guy over just because it's negative. So then it'll look like this. 2L2 on m minus x cubed equals 2L1 on x cubed. Still good? I'm not doing anything fancy. What would you do in your next step when you see this? Cross multiply. That's it. 2L2 x cubed 2L1 m minus x cubed. Looking weird, right? Now a lot of students would incorrectly expand this now. The problem with expanding this, you're going to have x cubed, x squared, x. You just screwed up. Don't do that. What do you think I'm going to do then? If I'm not going to expand, what would be beautiful? Beautiful. That's it. Now, it looks weird, but it's actually the only thing you can do. So we're going to cube root everything. So it's going to look like this. So just wait. Cube root of 2L2. But now at least you have this as x. True? One more time. Cube root of 2L1. And then what do you have here? M minus x. I think you've got room in the next page, so don't feel like you need to squeeze it in. Obviously, again, one last time, it's worth 4 marks, 9900. So me, when I was doing this at your age, I would have gone, yes, exactly what you're thinking, WTF. Then I would have said, no problems, I'm going to just teach my hand to write this again and again until my hand can get used to it first. Let alone my brain. My brain will be the last one. My hand's just got to get used to writing this because this is super weird. Just letters. So just repeat. Don't worry about understanding it. Just repeat it when you're at home. Just repeat it a few times. Then you'll actually get it. At this stage, I'm going to expand the right-hand side because that's all I can do. Right? Because I want x by itself. So I want to expand and then bring x's on one side. So watch. Cube root 2L2 x equals cube root 2L1 m minus cube root 2L1 x. Makes sense, doesn't it? I'm not doing anything fancy, like I said. Your hands just got to get used to it. What would you do at this stage?
Wouldn't you take the
Cube root 2L1. You mean the other one to the other side. It's easier. Because you want the x's on one side. So you might as well move this guy to the left. So it'll look like this. Cube root 2L2 plus plus cube root 2L1 x equals cube root 2L1, and then that's a closed, because remember that's cube rooted, and then we multiplied it by m. That's why you guys see me do this. So I know that's stop. That m's not included. So stop and then m. It's not you have to know. I think just for yourself, you might get confused and in the next line, I've seen that some students just put it in by accident. You lose a mark. After all this beautiful work and you put it in, you lose 1 mark. You don't want that. We are 1 step away, or 2 steps, depending on how you see it. Again, on the left-hand side, what are you going to do now? Obviously, you can't add them, but you just want a single x. So what would be the F word? You're going to say factorize, and then we're pretty much done, aren't we? You would say divide it after this. Let's go up and divide. Finished. Oh. Boom. True. I've done nothing crazy. I bet you if I had given you just letters and numbers, you guys would have smashed it out. There would have been no problem. It's because it's just letters, it gets weird. Just hand. Let your hand write it a few times. They're done. That's it. That is the expression. But there is a point where the sum of this note, find an expression for x. Okay. Now listen. What haven't we done? What haven't we done? So we just did. What did we do? Maybe we should talk about that.
Done everything for x and down.
Sure.
We've only done p.
P. What's p? Oh, that's okay. Does it say in terms of p? No, it doesn't say. Find expression in terms of m, L1, and L2. That's what we have. M, L1s, and L2s. So it's done. But what haven't we done? Or what did we just do? We found our stationary point. What haven't we done then? Nature. How do you know it's a minimum? What if it's a maximum? Don't do that, remember? Prove. It needs to be proven. So what are we going to do now? You're going to do 2 methods. Which one? If you're going to go y double dash, let me have a look at it. Y double dash, differentiate that again. Yeah, that doesn't seem too bad. All right, I'm going to go y double dash. I'll do y double dash. It's actually not that bad. We'll be okay. So let's go y double dash. I've got to zoom it out. Actually, I'm going to copy that. That's why. I think you guys don't forget the point of when I say 9900. Don't ever scare yourself. Like your average person in your school, or even your best student, extension student, won't be able to do this. So it's not made for them. It's made from 99, 100. Do we get that difference? Someone's got to come first, which is 100. Someone's going to come second, 99. This will differentiate those two people. It's not made for just getting a band 6. So band 6 students, they don't need to worry about this so much because they won't get it out. If you want to get to 9900, you've got to know how to do it. So don't let it scare you, I'm trying to say. 90 is still good. This is to go one extra level. Nature now. You guys can't, you're still stalling when I ask you, what are we meant to still do? You're meant to just know stat points and nature. You've got to stop stalling. Straight away, that's all you're doing. Every question, every single question. Stat point, nature. All right, well, I am going to differentiate, like I said, a second time. E squared n on dx squared. All right, here we go. Differentiate second time. Bring the negative 3 down. 6. L1 x negative 4. Bring the negative, well, that becomes positive 2, doesn't it? So I'm just going to do that. So then when I bring this guy down, that's going to become negative 6 L2, and then m take away x to the power of negative 4. Okay, for it to be a minimum, it's got to be greater than 0. We're going to say a few things. Let's go. So, equals 6L1 on x to the 4 minus 6L2 on m take away x to the 4. True? Now, obviously, what letter are we going to substitute back in? What letter are we meant to substitute in? At x. Good. Which we're not going to write it, but x is this thing. I'm just going to use a star with the circle. Is that okay? All right. What do we know? We know that all of these lengths are positive. Sure? We know this whole thing up here, x, is always positive. Can we conclude that? Why? Because L is length and loudness, M is length, has to be positive. The only problem we're going to have is this bit here, M minus X. The fact that M minus X can sometimes be negative. You agree with that? But it's power of 4. Yeah, if it's power of 4, you now know M minus X is always positive. The only other thing I can see, so far, this is positive. We agree with that? And this is positive. We agree with that. My only problem is this whole thing has to be now positive. Cool, because what if this was 5, take away 6? They're both positive numbers, but that becomes negative all of a sudden, which is not what we want. So we have to somehow conclude this one is going to always be smaller than this one. Now, think. Think. And let me make sure I get the right conclusion. Positive values. Looks like the HSC, they were a bit lenient here. Maybe I'm overcomplicating it. They just said as long as students stated all positive values were, or all of that values are positive, it's greater than 0, it's fine. But I don't like it because like I said, if it's 5 take away 6, you got to be careful. You're not always going to be able to get away with that. So give me a second. Let me just think about how we're going to say this is always smaller. M take away X. M take away X. M take away X is larger than X. So a number that's divided by a larger number will be smaller. Let's go back. All right. So M take away X. M take away X is larger than X. We agree with that? Now, a number divided by a larger number is what? Smaller. Do we know that? Think of 1 over 2 compared to 1 over 5. 5 is bigger, but 1 over 5 is smaller than 1 over 2. So as the bottom gets larger, the whole number gets smaller. So this is technically larger than this guy here. Sorry, this guy here is smaller than this guy here. Sounds good? But let's conclude now. At this, L1, L2, M greater than 0. True, we have to actually say that. L1, L2, M greater than 0. Distance, whatever you want to say. X4 and M take away X to the 4, also greater than 0. But 6L2 on M take away X4 will be smaller than 6L1 on X4, since M take away X4 is bigger than X to the 4. Finished. It's everything we just spoke about in math, in words, I guess. We spoke about in words. Yeah, wow. But now, but do you guys get when I say 9900? I don't say that all the time. If I say band 6 question, it just means you're going to be 90 plus. When I say 9900, it means you're going for top of the state. First in the state. The whole state, right? That's how I think. You've got to think like that. And that's it, finished. Therefore, X equals, star is a min noise level. Noise. Maybe instead of is, let's say gives. And that makes more sense, doesn't it? X gives a minimum noise level. Okay. Yeah, next question. Loudness. When you see that, be aware. As I said, it was just in your Catholic trial, so if you guys have done this year, that would have been in it. So let's say last year students, if they ran away from it when we did it, they would have came back and did them in their trial. So don't run away. Just, I hate it as well, you hate it as well, I'm not disagreeing with you. You gotta sit down and just write it out a few times. You'll be surprised. Okay, max min in geometry. You thought it couldn't get worse. It does. That's the good news. Not much of good news, is it? Wait. No, this is still 9900. All right, Rad's here. Let's stop.